The universe is expanding. We've all heard it before, like a balloon slowly inflating, stretching across the fabric of space and time. But what if I told you that this isn't just a quirky fact of cosmology, it's actually terrifying? A silent, invisible force is pulling everything apart, and it's doing it faster and faster. Not only is the universe expanding, but it's accelerating. And that single detail changes everything. It reshapes how we view our place in the cosmos, and it casts a chilling shadow on the fate of everything we've ever known. Imagine standing on a planet billions of light years away, looking at the night sky. To you, it would appear mostly dark. Not because stars don't exist there, but because light from distant galaxies would never reach your eyes. The expansion of space would be carrying them away faster than their light can travel toward you. That's the future we're heading toward. Right now, we still see a glorious sky full of stars and galaxies. But one day, the only things we'll see are the closest ones, maybe only our own galaxy, maybe not even that. Everything else will have disappeared, not because it ceased to exist, but because space has stretched so much that the light from those objects can no longer catch up. The night sky, once a vibrant map of the cosmos, will become a dark, lonely canvas. Let's rewind for a second. It all started with a bang, literally the Big Bang, around 13.8 billion years ago. Everything we know burst into existence. Space, time, energy. It all came from an unfathomably small, hot, dense state. But it wasn't an explosion in space, it was the expansion of space itself, and that expansion has never stopped. In fact, it's been getting faster. We used to think gravity would slow the universe down, maybe even make it collapse back in a big crunch, but the discovery of dark energy shattered that assumption. In 1998, astronomers observing distant supernova stumbled onto something unexpected. The light from those ancient explosions was dimmer than it should have been. That meant they were farther away than anticipated. The only explanation? The expansion of the universe was speeding up. It wasn't slowing down like a ball tossed into the air, it was racing away like a rocket with no brakes. That moment changed cosmology forever. It introduced us to one of the strangest, most unsettling forces in the universe: dark energy. A mysterious pressure that counteracts gravity and drives the acceleration, and we still don't know what it is. Dark energy makes up about 68% of the entire energy content of the universe. That's nearly 3/4 of the cosmos, and it's invisible. It doesn't interact with light, doesn't clump into stars or planets, and yet it's the dominant factor in our universe's evolution. Let that sink in. The fate of everything we see and know is controlled by something we can't even detect directly. So, what does that mean for the universe's future? Here's where it gets deeply unsettling. If dark energy keeps doing what it's doing, just steadily accelerating the expansion, then galaxies will drift apart, stars will burn out, and black holes will evaporate. This scenario is called the heat death of the universe. An era where everything is so spread out and energy so diluted that nothing new can happen. No stars, no life, just particles drifting in an endless, cold, dark void. That's not science fiction. It's the most accepted theory for how things end. But there are more dramatic possibilities. There's a version of the future called the Big Rip, and it's as apocalyptic as it sounds. In this model, dark energy doesn't stay constant, it grows stronger over time. Slowly at first, but then exponentially. Eventually, it becomes so powerful that it tears apart galaxies, then solar systems, then planets, and even atoms themselves. The very fabric of matter unravels. Time and space themselves might come to a catastrophic end. The idea that everything, even the laws of physics, can be ripped apart is enough to make your skin crawl. And again, we don't know that this will happen. But we also don't know that it won't. You might be wondering, why is this happening? Why is space expanding in the first place? What's it expanding into? These are the kinds of questions that twist your mind into knots. Space isn't expanding into anything. Rather, the distances between things are increasing. Think of raisins and dough rising in an oven. The dough itself expands, and the raisins move away from each other not because they're moving, but because the dough is. That's what's happening to galaxies in space. They're not flying away on their own. The space between them is stretching. But if you zoom in, you'll find that gravity is strong enough to hold things together locally. That's why the Earth doesn't move away from the Sun. Our solar system isn't expanding. Even our galaxy, the Milky Way, is intact and gravitationally bound. It's the vast spaces between galaxy clusters where expansion dominates. Over time, the cosmic web, the large-scale structure of the universe, gets thinner and sparser. Filaments break apart, islands of matter drift into isolation, and eventually, they vanish from view entirely. The part that's really hard to grasp is how time fits into all this. When we look deep into space, we're looking into the past. The farther away a galaxy is, the longer its light took to reach us. But because the universe is expanding, that distance is always changing. Some galaxies are already so far that their light will never reach us, no matter how long we wait. There are things happening right now out there that we will never see, because the universe is expanding faster than light can travel. It's like running after a retreating shadow on an accelerating treadmill. You'll never catch up. Some scientists believe that maybe, just maybe, dark energy isn't constant. Maybe it will decay or evolve. Perhaps the expansion will slow or even reverse. A big crunch could still be possible, collapsing everything into a singularity and resetting the cosmic clock. Or maybe a big bounce follows, where our universe is just one in a cycle of endless expansions and contractions. But those are just hopes, mathematical possibilities that aren't yet supported by data. As far as we can tell, the expansion is real, it's accelerating, and it's forever. There's also the haunting idea that we might be in a bubble universe, that our cosmos is just one pocket in a vast multiverse of other inflating bubbles. Some might have different physical laws, others might be collapsing. Ours just happens to be inflating right now. That view doesn't exactly comfort anyone, it just makes the mystery even deeper. We don't even know if the rest of reality is accessible. For all we know, we're prisoners of our own cosmic horizon. Even scarier, the expansion could be hiding something. What if the signals from other civilizations, if they ever existed, are simply too far away to reach us now? What if we're truly alone, because life is rare, but because the fabric of space itself has erased all traces of company? The longer we wait, the more that silence becomes permanent. The cosmic radio goes quiet. And one day, no matter how advanced we become, there will be no way to send or receive messages beyond our local neighborhood. The expansion will have walled us off forever. So what can we do about it? Nothing really. We can't stop the expansion. We can't slow it down. We're passengers on a ship whose course was set long before we existed. But what we can do is bear witness. We can observe, understand, and explore while we still have access to the cosmos. We can gaze at galaxies that will one day vanish, and cherish the fleeting moment in cosmic history where the universe is still visible to us. Because one day, it won't be. Astronomy isn't just about stars and telescopes. It's about confronting the grand, sometimes terrifying truths of existence. And the expanding universe is perhaps the most humbling of them all. It tells us that change is constant, that nothing lasts forever, and that we are part of something vast and unstoppable. But it also reminds us of the incredible privilege of being here now, at a time when we can still see the stars, still explore the cosmos, and still ask the biggest questions of all. So the next time you look up at the night sky, remember, you're not just seeing stars. You're seeing a moment in cosmic history that will never come again. A brief window before the lights go out, before the universe pulls itself apart in silence. That's the terrifying truth of the expanding universe, and also its most beautiful gift.